Hi there, thanks for coming. This is a demonstration of the power of a vacuum. And the reason I'm doing these testing is to show that I can make a dirigible that's got a geodesic structure, and if I take out the air inside, the structure itself will float, just like a ship floats on water. So let me just show you a vacuum. Okay, this is just a water bottle. I'm putting this machine on it. And here you can hear it sucking in. And the vacuum broke. Let me do it again. And if I release it, comes back. Okay, well, I'm going to tell you something that surprised me. This is another juice bottle, but it's a little stronger on the wall. Let me get this on over the little pinhole. I didn't expect it to last as long as it did. Sorry about that. It startled me too. Okay. So I can take that off. And now I'm going to apply it to this one. This is you buy this at Home Depot, this foam core. It's 1/2 inch thick. Okay, I'm almost up to a complete vacuum. And there it comes back. Okay. And I know I'm talking to the small personal blimp people, and they said, okay, make a big one and see and weigh it after you do it. Well, I don't need to weigh it. I just have to get the vacuum that I show. And this is a pyramid made of 4 sheets, and this is just the foam. Now, I could make, if I just made a geodesic 100 feet in diameter with just these triangles, I would be able to evacuate it and make it float. But I'm going to try and actually make it a little bit larger and see if I can get within the tolerances of this thing to see how, if I make this twice as big, I use 4 times fewer of these little triangles, so 4 times less labor. So that's what I'm going to do next, to see if I can get double the diameter and the length of the things here, so it'll be 4 times bigger, and maybe we'll get something that I can test later, bigger, and see if this will. I was expecting this to depress a little bit, but it didn't. And I know I had the vacuum because I could watch the dial and have it go up to completely evacuated, or 90%. Anyway, keep going towards the geodesic dirigible with a vacuum. Now, what's next about a vacuum? A vacuum is always available. All you need to do is have a compressor and the gasoline to evacuate the geodesic. Okay, and I'm planning to make that half a vacuum. Why? Because if I need more lift, I just evacuate it a little bit more. Okay, so then if you take it on, you evacuate it a little bit, you can just fly off. Okay, so now when you fly to another country, you don't have to drop ballast water. Okay, there's some issue with that. Maybe you bring some fish or some parasite. So there won't be any of that. There's no fire hazard with hydrogen, okay, because it's a vacuum. Actually, it'll put out a fire. Okay, finally, it's not expensive like a helium. Maybe it'll take maybe 5-10 gallons to evacuate this 100-foot diameter geodesic. Well, I don't know about you, but the price of helium would be astronomical, in the hundreds of thousands of dollars to cause lift for this. And like a hot air balloon, it'll float, but you don't have to keep on heating it. Now, if I have this insulating stuff on it as a sphere, 100-foot diameter is going to take a very long time to cool off, just by the laws of physics. So you could make this and make it a hot air that would stay aloft for maybe a couple $100 worth of propane. So this has got all sorts of advantages and none of the disadvantages of other flotation systems. Okay? So once you get it aloft, all you have to do is continue to keep the vacuum. Okay? You can always find a hole because you can put a little smoke. I mean, it's just all the advantages go on and on and on. And I see the people in the small blips forum struggling with all the other issues, trying to make it fly with hydrogen and all the other crap. A vacuum is environmentally friendly, doesn't cause problems, and it just works. And then people are surprised about the vacuum. You know, you see on the tank, if you go Google on the stuff on YouTube, they show this tanker collapsing just like made out of steel, just like this did. Well, this deals with compressive forces. This structure, this geodesic, deals with compressive forces very well. So that all the compressive forces are along the edge here. You straighten that, and as long as the material in the middle can survive a vacuum, half vacuum, you know, you'll have something that can float in the air for years. Thank you very much.